Hello everybody and welcome to the fourth video in our statistical reasoning series. Today we're going to look at standard normal curves and z-scores, and this is going to be a two-part topic, so this is just our first video. We're going to look at the basics. Overall, you can read that yourself, but overall z-scores they're a really great statistic, and why they're great is they help you compare things. So that's really what we're going to be learning today, is how to compare things. So this z-score does it by converting scores in just normal curves into this standardized normal curve, which you're going to learn more about in a second. So here, a standardized normal distribution. Well, a standardized normal distribution is a basic normal distribution. So it's just the normal distribution that you know about, that bell curve with an average and standard deviations. But now they've made it special because the average is always 0, the mean is always 0, and the standard deviation is always 1. So in the previous video, we looked at normal curves, but the mean might be something like 7, and the standard deviation could be like 2.4. Well, in a standard normal curve, the mean is always 0, and the standard deviation is always 1. And why we do that is it helps compare things. So now you can compare, and I'll draw it up here. You might have one situation, maybe we're dealing with fish in a lake, and the one type of fish is the same type of fish, two different lakes, but maybe, you know, in the one lake they have an average weight of 3 pounds and a certain standard deviation. Now in a different lake they have an average weight of, say, 3.7 pounds, and they have their own standard deviation. Well, how do you compare them to each other, really? Well, you can compare them in this standardized normal curve. We can put them both into the same type of normal curve. Okay, so that's what we do with these standardized ones. And that's what a standardized curve looks like. You can see the mean is 0, and then the standard deviation is 1. All the percentages are the same. So the 34% and 34%, all that is still true because it's still a normal curve, but now the mean and the standard deviation are fixed at 0 and 1. How to calculate the z-score? Okay, it's a formula, so that's great. Pretty easy. So there it is there. And now what all that represents, z is your z-score, x is a data value that you're wondering about. So this is the thing you're wondering about and how it ranks compared to other data values like itself. So maybe it's that we caught a fish and we're wondering how it compares to the rest. X, with the bar over it, that's the mean, and then we have our standard deviation on the bottom. Now, what goes hand in hand with a z-score is a z-score table. The z-score table tells you how it ranks to the other items in that data set. So you'll find this z-score, and then you're going to use this table to tell you how much larger it is, or the percentage of things it's larger than. That's a better way of saying it. So once we have the z-score, we can use the z-score table to determine the percent of data above, that's supposed to say, or below our value. A positive z-score means it is above the mean, and a negative z-score means it is below the mean. And there's a little extra thing here, just telling you about where this formula comes from. The formula to calculate a z-score is derived from the fact that a data value from a normal distribution can be calculated with this little formula, which is really just the average. This is another way of writing an average. The software I had to use at school that at that time didn't have the X bar for some reason. So the average plus Z standard deviations, where Z is just the number of standard deviations. That is optional, guys. This is optional. You don't need to use that at all in this video, but just if you're wondering where that formula came from, it came from that. Okay, so this z-score table. Once you have a z-score, you then look up the percentage of data that this thing is larger than. And I'm sorry if I'm saying that kind of funny. When we see some examples, it'll make more sense, I'm sure. Some of this is kind of hard to describe without doing examples. So that's why I'm kind of just going over it quickly, and then when we're doing examples, we'll get into it more. But anyway, how to use this z-score table? Well, you'll have a z-score. Let's say it's negative 2.48. Now you can see here in this column, it's just the number and to the tenths. So, and then over here, we're looking at the hundredths. So really what you want to break your number into negative 2.4. And then you want to look at 0. I guess in this case, 0.8. All right, so negative 2.4 is right here. The 0.08 is right here. What we do then is we then go look down the column and the row until we see where they meet, and that'll tell you the percentage of data that this value is larger than. So this is really a percentage, and but it's in decimal form, so it's, what do I have here, 0066, then I times it by 100, and I see that my data value is larger than 0.66% of the data. Meaning if I drew this up, to give you the bit of a visual here, here's my mean is 0. What was my z-score? Negative 2.48. So that's pretty, that's quite negative. Okay, negative 1, negative 2, negative 3. So negative 2.5 basically is right here. So if I shade this in, this shaded area, that's all the stuff that my data value was larger than, and that works out to be 0.66%. So a really small percentage. Meaning then, conversely, that this data value right here is smaller than, what would that be? 99.4 gets me to 78.34%. 99% of the material is larger than that data value. So that's really a really small z-score. There's also positive z-scores. Okay, remember when you're positive, you're larger than the mean. So that z-score, let's think of something like 0.47, I'll say. And same thing, I got to really break this up into 0.4 and then 0.07. So here's 0.4, here's 0.07. Look down, look across. That's my value, that's my percentage really. So I'd get 0.68. 0.08 times it by 100 to convert to percentage, 68.8%. If I drew that, that means my data value, oh, sorry, let's draw this, 0, 1, 2, 3, negative 1, negative 2, negative 3. So 0.47 is roughly in the middle here, right? So the z-score always tells you the percent of the data to the left of it, okay, to the left side, meaning it is larger than 68% of the data. And then conversely, that would mean it was then smaller than 32% of the data. So you can figure out how it lies within that data set. So that's a z-score. They're pretty easy, or the z-tables, they're pretty easy to read from. Okay. Sorry, my recording just kind of went funny on me on my end. Anyway, let's get into some examples. So, yeah, determine the z-score for each x, for each value of x. So this value of x, that's the data value that you'd be bringing out of a problem, okay? It's a formula, right? So it should be pretty easy to deal with. There's your formula if you forgot. And then you simply plug things in. So there's my x value, so 250, minus my average, which is 200, divided by the standard deviation, which is 25.4. So do the math, 50 divided by 25.4, and that works out to 1.96. So I have a z-score of 1.96. I then would go to my z-table, which we'll do in the next example. Let's do B, just again, actually calculating the z-score. Start with my formula. And yeah, work things out. So now it's 17 minus 18 divided by 2.2. Works out to negative 1 over 2.2. And when I do that division, it works out to negative 0.45. So I get a z-score of negative 0.45. Hey, just a quick reminder while we're doing this, seeing this as a formula, remember, we in theory might have to solve for any of them. So right now we're always finding z, but you're going to see in our second video we'll start to, and maybe even this one, we'll see how things go. But in our second video for sure, at some point we'll find the x, or we'll solve for the mean, or we'll solve for the standard deviation. We'll start solving for other things. Okay, question 2. Using the score table, determine the percent of data to the left of each z-score in question 1. Okay, well I forgot to mention something at the start of this video. For this video, you're going to need a z-score table. Now, I will have one posted for you, so you simply have to print that off, but you're going to need that for this assignment. So, our z-score for the first one was 1.96. So you want to look at the 1.9 row and where that meets the 0.06 column. And if you do that, you'll end up getting 0.9756. So make sure you try this, everybody. Feel free to pause the video to go do what you have to do to get that sheet. And you times that by 100 equals 97.56%. And again, I like the visual. Maybe you don't like the visual, but I like the visual. So here's 0, 1, 2. So basically we're at 2, which means this data value is larger than 97% of the data out there. So that's a really big data value. B, our z-score was negative 0.45. So you want to look at the negative 0.4 row and where it meets with the 0.05 column. And you end up getting 0.3264. And again, times that by 100 to convert. And I mean, you can go directly to this. You don't have to actually write out the percent, the decimal, and then times it by 100. You can just go straight to this if you want. And again, visual of it. Here's 0. Here's negative 1. So it's roughly here. So that data value is larger than 32.64% of things, and which means it's smaller than our 67%, you know, roughly, whatever that works out to. Okay. Now question 3, using the score table, determine the percent of data to the right. So I just kind of answered that for B. So if you want to know what is to the right of it, now by to the right of it, I mean what's in this blue area in both of these. Know that the area underneath this, in this normal distribution or standardized normal distribution curve, like any normal distribution curve, adds up to 100%. So all you have to do is find the percent. If you know the percentage of data to the left from your z-score up here, you simply just go 100 minus 97.56 and work it out. So that ends up being 2.44% in this case. Another way of doing that, it's kind of neat in these z-scores. If you just find the value of the opposite z-score, so that'd be negative 1.96, you'll see that if you check out your chart, it ends up being 2.44%. So either way you want to do that. In B here, again, the first way of doing it is go 100 minus the data to the left, and that'll leave you with the data to the right. So it ends up being 67.36. Or figure out the z-score for now. The opposite would be positive 0.45, which again works out to this 67.36. All right, so now we've found z-scores and we've gone to the tables. And the next question, determine the percent of data between each pair of z-scores. So what do I mean by that? I mean, well, we're going to have two z-scores. So let's say this was our first z-score. I'll say Z1. And we know our percent of data here. And let's say we have another z-score. I'll go a different color. Right here. That's z-score 2. What we're going to wonder about is, well, how much data is lying in between? Okay, what's the percent of data between them? So in general, if you just saw there, we want to find the difference. If you're ever looking for a difference, you guys, we always go big minus small. So I'd use my percentage from this Z1 and I'd subtract the percentage from Z2, and then that would leave me with this yellow area here, which would be the difference between them. Okay, so that's how we're going to work through these. Let's just do this. So I'll say Z1, and oh, sorry, our z-score, we already got the z-score, right? I was going to calculate it. So if my z-score is negative 2.12, sorry about that, that works out to a percentage of 1.7%. So you'd have to look that up in your z-score table again. And then for the second one, which is negative 1.33, that works out to a percentage of 9.18%. So that's your first step, is find these percentages. And the second step, you could find the difference between them. So to find the difference between them, just go with a larger one, so 9.18%, minus a smaller one, 1.7%, and then that equals 7.48% if you check that in your calculator. All right, so the first step will always be find the percentages. Second step would be the difference. Okay, so for the first z-score, 0.85. The percentage for that guy works out to be 80.23%. The z-score for the second or the z-score of 1.24, the percentage for that one works out to be, it's larger, right? So it's going to even be higher, 89.25%. And we're wondering about the difference between them. I'd go the larger one, 89.25, minus the smaller one, 80.23, and then that works out to be 9.02%. So that is how you find the percentage of data between two z-scores. You find the percentage for both z-scores, and then you just subtract to find the difference. Okay, our final example for this first video, because I'm just worried about it getting to be a bit long, but I don't know, it doesn't feel too bad thus far. Anyway, determine the z-score for each situation. So we'll just get going on this one. Now, this one says we want to know 15% of the data, or 15% of the data is to the right of the z-score. Okay, we know that 15% of the data is to the right of the z-score. And the other thing about this is they didn't tell me the mean, they didn't tell me the standard deviation, so I can't use my formula for this question. So if I know that 15% of the data is to the right, and I'm going to draw that. So on the right side would be 15%. This is my z-score I'm wondering about. Well, then that means 85% of the data is to the left. And remember, the z-score table tells you the percentage of data to the left of your z-score. So really what I can do is look in my z-score table for something that is close to 8.8500. And if you scan that, so now what you're going to be doing is looking at the middle of your z-score sheet, and you're going to be wondering, can you find, like what z-score associates with it? And you'll see when you scan that thing, z-score of 1.04 is what comes out. Okay, so we don't necessarily need to use the formula to find the z-score. If they give us other clues like this, then we're good as well. B, 57% of the data is above the z-score. Okay, so above seems kind of funny, a way to phrase that. But here's our z-score again. Above means simply to the right. So they're saying that 57% of the data is above or to the right of the z-score, which means then that 43% is to the left. And again, the z-score always tells you, or the z-score table always tells you the percent to the left. So we always need that value to the left if we're going to use that z-score table to find our z-score. And again, you just scan your z-score table so for something that's close to 0.4300, and it might not be exact because we only have so many decimal places on that z-score table, but the closest one you're going to find here is negative 0.18. Okay, so that is z-scores and standardized normal distribution. I hope it makes sense. Remember, there's a second video to watch now where we're going to look at some problems. So that's going to be a short video, but I just didn't want to make this one too long. So if you're having trouble, make sure you get talking to your teacher or myself. Have a great night.